Hello everyone. Today we will discuss the key differences between IPv4 and IPv6. These two protocols are essential in computer networks and play a crucial role in how the data is transmitted over the internet. Now let us see the overview of IPv4 and IPv6. So IPv4 and IPv6 are versions of internet protocol used to identify devices on a network. IPv4 was introduced in early 1980s and has been widely used since then. However, due to its limited 32-bit address space, it can only support 4.3 billion unique addresses. To overcome this limitation, IPv6 was introduced, offering a 128-bit address space, significantly increasing the number of possible addresses. Besides the larger address space, IPv6 also provides better security and efficiency. Now let's see what is IPv4. IPv4 uses a 32-bit addressing scheme where IP addresses are written in dotted decimal notations such as 192.168.1.1. Due to its limited address space, techniques like network address translation that is NAT and subnetting are used to extend its usability. IPv4 also supports broadcasting where data is sent to all devices in a network. However, this feature is not present in IPv6. Now we will see the IPv4 header structure. The IPv4 header is a structured format that contains important information needed for packet transmission over a network. It is 20 bytes to 60 bytes in size and consists of various fields that help routers and devices understand how to handle the packet. So, first is version, which is of 4 bits. It specifies the IP version, always IPv4, always 4 for IPv4. Next is Internet Header Length IHL, which is also 4 bits, which specifies the header size in 32-bit words. Next is Type of Service, which is of 8 bits, defines how the packet should be handled. Next is Total Length, which is of 16 bits, specifies the total packet size, header plus data. Next is Identification, which is of 16 bits, used for packet fragmentation and reassembly. Next is flags, which is of 3 bits, which controls the fragmentation. Next is fragment offset, which is of 13 bits, which indicates the position of a fragment. Next is time to live TTL, which is of 8 bits, limits the packet's lifespan to prevent the looping. Next is protocol, which is of 8 bits. It defines the transport layer protocol. TCP is equals to 6 and UDP is equals to 7. Header checksum, which is of 16 bits. It ensures integrity of the header. Next is source address, which is of 32 bits. Identifies the sender's IP address. Next is destination address, which is also of 32 bits. It identifies the receiver's IP address. Next is options, which is a variable options parameters for additional control. Now let us see the IPv4 features. First is address classes. It divides addresses into 5 classes like A, B, C, D, E based on their uses. Second is the header size. For IPv4, it is 20 bytes containing fields like source, IP, destination IP, TTL, protocol, and checksum. Third is routing. It uses hierarchical addressing with class 4 or class rest routing. Fourth is security. For IPv4, there are no built-in security. It relies on external protocols like IPsec, SSL, TLS, and VPNs. Fifth is manual configuration. It requires manual IP configuration in many cases, unless using DHCP, that is Dynamic Host Configuration Protocol. Now we come towards the IPv6. IPv6 was standardized in 1998 to address the limitations of IPv4. It uses a 128-bit addressing scheme allowing for about 340 unidecillion unique addresses written in hexadecimal notation separated by colons like 2001 colon DB8 colon 1. IPv6 also supports automatic configuration without relying on DHCP thanks to the stateless address auto-configuration SLAAC. Additionally, IPv6 provides end-to-end connectivity without the need of NAT, simplifying the network architecture. Just like IPv4 header, we should also see the IPv6 header structure. The IPv6 header is the main control structure in an IPv6 packet, containing essential information for routing and processing data across networks. It is fixed at 40 bytes, unlike the variable length in IPv4, improving efficiency and reducing processing overhead. First is version, which is of 4 bits, which identifies the IP version. It's always 6 for IPv6. Traffic class, used for packet prioritization and quality of service. Next is flow label, which is of 20 bits. It helps in identifying and handling packets belonging to the same flow. Next is payload length, which is of 16 bits. Specifies the size of data being transmitted. Next is the next header, which is of 8 bits. It indicates the type of next header. For example, if it is TCP, UDP, or extension header. Next is hop limit, which is of 8 bits. Replaces the TTL in IPv4, limiting the packet's lifespan. And the next is source address, which specifies the sender's IP address. And the last one is destination address, which specifies the receiver's IP address. Now let us see IPv6 features. Addressing types. It supports unicast, multicast, and anycast addressing, but not the broadcast. Second is simplified header. It has 40 bytes, reducing speed overhead, reducing processing overhead. Next is enhanced routing efficiency. It uses hierarchical addressing and IPv6 prefix aggregation. Next is security. It has built-in IPsec, that is Internet Protocol Security, for encryption and authentication. Next is SLAC, stateless address auto-configuration. In this, devices can generate their own addresses without DHCP, that is Dynamic Host Configuration Protocol. Here's the quick comparison of the key differences between IPv4 and IPv6. First is address size. IPv4 uses 32-bit while IPv6 uses 128-bit. Address format. IPv4 uses dotted decimal format while IPv6 uses hexadecimal format. Security. IPv4 security is optional while IPv6 has built-in IPsec. Broadcasting. Supported in IPv4 but not in IPv6. Configuration. IPv4 often requires manual configuration or a DHCP, whereas IPv6 can auto-configure. Header complexity. IPv4 headers are complex and variable, while IPv6 headers are fixed and simpler. Thank you for watching. I hope you have now clear understanding of the differences between IPv4 and IPv6. This is Viraj signing off.